good morning. So, Corey, you need a sheet? No. You have molecular geometry due today. You've had that about a week. A lot of you have already handed that in. Let's get ready, please. And your quote-unquote lab, the one that we did the ball and stick models, that is due by Friday. You should be able to get that done by then. And then the review, which will help you a lot with your test, that'll be due Friday. So those are the two things you'll be working on moving forward. And a lot of you have already handed actually in that lab as well. Again, that was with those kits with the atoms and the bonds. So today we're going to go over just a sheet that will help you kind of understand what is required from you for your test. We have some different tiers. Let's please be with me. We don't want to have to not to do well on Friday. So there's different parts to this test. There's parts where can you just identify, and then there's parts where you're going to have to go from scratch. So we're going to do kind of both. We're going to do it together. I'll let you do some, I'll do some. So I'm going to do the first one with you. For some of you, you're probably at a point where maybe you can go faster through this, and others, you might need a little assistance yet. Regardless, let's not be confused with the idea that we aren't going to be having the Vesper sheets on Friday. I've been saying that since the beginning. If you've been still using that as a crutch, that's going to be a problem. Mr. Blackford.
Wait, no Vesper sheets?
Absolutely no Vesper sheets.
So we don't have any cheat sheets?
No, you have the periodic table.
The periodic table?
Yes.
The rest of the shapes and stuff we have to know?
Yes, sir. So we have been learning, great question, young lad. We have been learning about these shapes for the last 2 weeks. They slowly should have been sinking in. You were coming up and getting stamps from us, although a few of you chose not to do that, working on those kinds of shapes and names and all that. So here we go, doing the first one. All these terms and everything you need to know. So I see a shape like this, steric number. Steric number is a fancy way of saying number of electron clouds on my center atom. So clouds count as single bonds, double bonds, triple bonds, and lone pairs. So I see 1, 2, 3, 4, 5 clouds. Just a second. Let's try that again. There we go. So I have 5 clouds. The minute you say 5, you should then go into a certain shape. Again, what I would try to do is not use my Vesper sheet at all today. So those of us that have it out, that's not going to help you any longer. Like that, you need to start figuring out how to do it without. So when I think of 5, I can try to come up with certain names. In this case, I already have it drawn for me. We're giving you a big help on this. I'll tell you now, 4 or 5 years ago, our test used to be 10 problems, all formulas, go. Nothing drawn at all. Just, do you know it or you didn't? Like that was brutal. Either you had it or you didn't. This, at least we can see if you have troubles with some of the drawing or coming up with it from scratch, can you still relate to it? So this is a middle triangle, so I would say trigonal. And then I have a pyramid going up, and I have a pyramid going down. So 2 is bi, and pyramid is pyramidal. Get the spelling close. Get the spelling close. So it's trigonal bipyramidal. What's the actual geometry of that? It's T-shaped. We do not count our lone pairs in our actual geometry. So you can cover that up with your hand or whatever else you need to do. But remember the actual shape, it could say actual or it could say molecular. It's the same thing. We're trying to use a little bit of both here. Hybrid is based off of the steric number. So the minute I say 5, I have to go through a process that we've been learning about. So I say S first, then I start saying Ds. I can only say 3 Ds. So then Ps. Let's start over. Say S first. You can say up to 3 Ps, and then a D. So this is sp3d. Bond angles. Yes, you got to come up with these. Just look at it. That is what? 90. I'm going to write it on here. Might not be a bad idea for your review. That's 90. Is there a 120? Bond angles have to be between bonds. Is there a 120? If this was an atom, this would be 120. That is not an atom. There's nothing here. If I cover that up, there's nothing else there. So there is no 120. It's just a 90. Now, if you look at your Vesper sheet, there is a 180. If you write that, that's great. If you don't, you wouldn't lose points, because the 90 would take care of it, because this would be the other 90. So if you wrote 180, because this is 180, that's great on either side. But you wouldn't have to do the 180. So 90 is actually all that you would need to provide for us. If you wrote 120, it is technically wrong, because there's nothing else on that triangle. There needs to be at least one other atom in that triangle. And then the last one, polarity. On this kind of column, if it's that big, we're not asking you to draw it. So simply, is that polar or nonpolar? What is confusing, many of you had frustrations with this, because when you say nonpolar and then you think symmetrical and asymmetrical and they sound like opposites. This is asymmetrical, so this is actually polar. It's not nonpolar. You're like, wait, but it's not symmetrical. Correct. It's not all even, so there's differences. So that means there's going to be poles. Poles are like charges. There's going to be a charge on one side or the other because it's not even. So that would be polar. Okay? So what I'd like you to do is give the next one a shot. Okay? That is only one atom. I know there's a little bit of a layer right there. There's only one atom. Right, that white one is only one atom. I think it's trying to do a shadow. If you're moving ahead, that's great. That's what we kind of feared. We were going to actually hide all these, but then we didn't want you to have to try to draw them. So try to do the next one. If you're working ahead, that's great. I'm going to give you just a minute or two to try to do this next one on your own, though. So give it a shot and see what we come up with. And then we'll go through it. You guys, I want to be clear. What is the steric number on this? Just so, because if you don't have that right. All right, so I'm not picking on her. I'm using her as a great example. McKenna misinterpreted that what I was talking about, if that one counted or not. So she said this was 3. If you lose a point on something, what we would do potentially, if everything she did was right, based on 3. So there's a certain way you wouldn't get all that wrong. Now, you can't play some game with us and be like, oh, I'm going to put 2 on the top and I'm going to put the same answer every single time. You got to clearly be attempting the problem the right way, and just clearly you misinterpreted what you were seeing, or however you answered it. It's called double jeopardy. You can't have double jeopardy in something like this. If you're answering things right to the initial situation, there's certain wiggle room. There's not complete wiggle room because the picture is pre-made, so it is important for you to understand what these look like. But there would be instances where if you had all this quote-unquote wrong, it could be considered right. So this is 4. So the minute I say 4, I better be thinking tetrahedral. So here's my question. Oh, I can just snap these in. I forgot about that. Tell me, I'm going to already give it away. Why? I know that this is tetrahedral. What would have to be present for my parent not to be the same as my molecular? Why are those different? What always has to be present? Lone pairs, right? If there are no lone pairs, they are exactly the same, automatically. So if I say tetrahedral, I'm going to say tetrahedral. Hybrid. I say 4, sp3. Bond angle. What is it? 109.5. And then is that polar or not? Polar or non-polar? Non-polar. I'll give you a big hint on that. Just a sec. Stay with me, guys, on these little hints. These are what really matter. In a picture like this, we aren't differentiating like one atom from another. You can assume they're all the same atoms. Please assume they're all the same atoms. But that one's white. It's trying to show depth. If you had the gray over a gray, you might not be able to see them both. If it's a parent geometry and they're all the same, it automatically has to be nonpolar. If it's a parent geometry and they're all the same, outer atoms, it has to be nonpolar because they're evenly surrounding. Even if you don't feel like it is. Well, there's 3 on the bottom and 1 on the top. You're thinking in 2D. This is 3 dimensions. They are always the same. If I keep flipping this, it's always exactly the same shape. So that means they're all pointing in opposite but equal directions. Okay? So, we're going to keep pushing forward. I see a lot of you working ahead, and that's great. Help me out with this, and then we're going to give you a couple minutes. Tell me the steric numbers. So this next one is, I want to just make sure we're reading them right. This is 5, 4, 5, 6. Okay, so take a couple minutes. We're going to be around if you need some help, but then we're going to fly through this. The next part will take a little more time, but there's only 3 of them because we're going to start from formulas, and we got to come up with the shape from scratch. But these are the ones, these are the points we got to grab on this test. We have to be able to do this. If we give you a shape, can you give us all the information from a pre-made shape? So if you have any issues at all, if you're all done with it, make sure you check with someone else by you. If you're having the same answers, great. And then we'll move into the next part. Try not to use your Vesper Sheet. You're done, you can just sit tight. Compare with someone else though. Let us help if you have any questions. That's the one I sent to everybody. Ah, I sent you guys the wrong one. Oh, that's so that's just the homework. You actually put the homework sheet. Yep, that's the homework sheet. Hold on, I'm not going to speak for a second. I sent you the canvas. But you're doing the homework, right? What's your question? So how many copies? All right. So when you get started into it, you guys, if you can kind of bring it back in, and it's kind of in and out, and it's good. But we want to make sure that we are also picking up little tips. Even if you're, hey, I got this. It's always good. This is about reinforcement right now and making sure that we hammer this home. Okay? So, again, pre-made shapes. The minute I say 5, it's got to be the same. It's got to be trigonal, bipyramidal. Whenever there's 5. Again, I have 2 triangles. So that's why it's bipyramidal. Okay. Actual shape. This one's a little hard to see. What's the actual shape on this one? It's a seesaw. It would have been better if this was the atom here and this was dots. I think it would have been a little easier for you to see. At least for me it is. But that's a seesaw. All right, hybrid. It's 5 clouds. It's the same as the first one. 5 clouds is 5 clouds. It doesn't matter how many lone pairs I have. So it's S, P, 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 D. So it's SP3, D. Angles now. Here we go. Here's the difference. This is still 90. Is there a 120? There is. On this triangle right here, that's a 120. I'm drawing it right on there so you can see where that is. If I had this shape, this is what I'm looking at right now. There is a 120 on that triangle. There's part of a triangle left. And a couple people have asked really good questions. Well, that's a lone pair. Wouldn't it actually push it a little tighter? That is awesome, and that is right. But we're not going to worry about all that so much, okay? Polar, non-polar? Polar. It's not even. So, all right, last 3. This one is 4, so tetrahedral. I'm going to write all the parent geometries actually right away. Oh, great. Six clouds. We haven't had that yet today. The name of that is octahedral. Okay, a couple quick things on this. When there's 3, we always say trigonal, but a lot of people that I was testing on in the last couple days, they had a hard time really differentiating what we do then. If it's flat, we say planar. When it rises, we say something with a pyramid, so we say pyramidal, right? And so on and so forth. I'm just going to do this last one. We're going to get to the bottom, and I'll come back up, because some of you I'm losing. Angle, 109.5 for a tetrahedral. It becomes 107. I add 1 lone pair. I reduce it by 2. And that is not evenly surrounded. I have 3 atoms kind of on the bottom. I have a lone pair on the top. That is polar. So that is the first 4. We'll come back and fill those in a little bit later. But let's get to the bottom half, please. Ladies, please stay with me. Please. It's starting to get a little bit of a distraction. All right, so first one. Is SF4. All right, so 3D structure. This is where now it all has to happen. You have to figure out what this all looks like. So I know I have center atoms. I know I have outer atoms. I got to figure out the bonds. I got to figure out the lone pairs. But it's all about the central atom. Okay, so what would I do? I'm going to just get you started here. I would think about what is my bonding. We're not going to have columns of T and V. That's for you. That's for you to figure out. So that's my initial structure. That's me assuming it has all single bonds. But where do I go from there? I have to look at how many electrons I should have. So that's looking at the periodic table. And the whole point is how many clouds. How many clouds do I actually have on my center atom? So right now I'm starting with 4. Do I stay at 4? Do I have 5? Do I have 6? Do I need extra bonds? So I have to look them up. So you have to look up SF4. So honestly, we should see numbers on the bottom. So I'll do one of them, or on the top, whatever. Like that is worth 6, because that's 6 electrons, 6 valence electrons, right off the periodic table. So how many valence electrons should I have? What does it all mean? Give you about 30 seconds to try to come up with some numbers, and then we'll come back together. Clearly, this is where people will struggle. Takes time. You got to put some time into it. We've been working on this. This was all molecular geometry 2. F is worth 7. So 7 times 4, 28. So I add those all together, and 6 plus 28 is 34. This only had 32. A difference of -2. Oh gosh, what does -2 mean? You can sit here and try to memorize negatives and positives, or you can just reflect on the fact that my picture has too many or too few electrons right now. Too few. I'm supposed to have 34. I only have 32. Remember, each line's worth 8. If you're not understanding my notation, I am visualizing that there's an F bonded at each of those lines. So I have to add more electrons because I'm short by 2. So what was all that for? Clouds. How many clouds do I have? How many clouds is this? It's 5, right? It's 5. 4 bonds, 1 lone pair. Okay, so what do? I only draw 5 different shapes: linear, trigonal, planar, tetrahedral, tetrahedral, trigonal, bipyramidal, or octahedral. Oh, the 5 and the 6. Those were the complicated ones. It's a stick with a triangle or a stick with a square. So this one, you draw the center atom, and you simply make an axis and a triangle. That's how you start. If you're trying to do all this other complicated stuff, it's not going to work. Can we deep plug, please? There's no reason. My voice is more lyrical than anything you could listen to. I have 1 lone pair. Suggestion, you always have to put it on the triangle. If there's 1 pair, I put it on the 1 bond. If there's 2 pairs, I put it on where the 2 bonds are. So if I put it on the 1 pair, it will reveal itself for the shape. So what is that shape? All I want is actual geometry. The actual geometry is, or molecular geometry. That's a seesaw. Hybrid, just what we've been doing before. There's some new stuff here, though. Hybrids, SP3D. Okay, now what the heck are these? Sigma is single. I can never write that. Pi is extra. So I don't see any extra bonds at all. So automatically, that's done. Those are 0. You can write a 0 or a dash. It doesn't really matter. Sigma bonds are only 2 bonds, though. A bond is a sharing of electrons between 2 atoms. So this is not an atom. So that is not a bond. So there are 1, 2, 3, 4. There are 4 sigma bonds. It's very important that you're understanding that it's only between atoms. Okay. Last thing, and this is where some people will fall apart. So it's important. You take your shape and you redraw it, but you don't need to do all the 3D stuff, but you do need to make the areas where the bonds are. You can't all of a sudden make something new and make it all randomized when that's the picture you drew. Well, where are my lone pairs? You can put them there. You can put dots if you want. You can put a line. I will say, if you do that, you might accidentally draw something on it. So you don't have to draw that. You have to make sure you draw your bonds, though. So I put the S's with the F. Like that. I just redraw it. And now we have to draw what we call dipoles. And a dipole points to the atom that will pull the electrons towards itself. Simply put, more to the upper right. So fluorine always wins, and look at that, we have a fluorine. So I draw little bond dipoles pointing towards the F. And if they all cancel out, it's like vectors. If they all cancel out, then it's done. There's nothing that we can do. But in this case, this is pointing up and down, and these both are kind of pointing to the left. So I can draw one really big one that is like an average. And because I drew that, polar or non-polar? Polar. It is polar. Okay. So we only have two more. And that one actually probably took the most time, to be honest. And as we're going, ask for questions like where did numbers come from? Other things like that. Actually, well, this one will take some time too. ICl, so that's an I, like iodine, and then chlorine 4, and then minus. What's up? Don't. So the electrons, great question. Why? What if I put the electrons on the top, like here, you mean? Like, they have to be on the triangle because the triangle is the furthest away. Like an atom is farther away from each other on the triangle than if they're here. Here, you're only 90 degrees from everything. Here, you're also 120 from here, so there's more space. So you got to put them on the triangle. Just, they have to. If they're not, you would like lose like a half a point or something. It would be wrong. So make sure you do that right. Okay, so please, if you're on the test on Friday, if you're having a question, if this is chlorine and iodine, I'm sorry, carbon and iodine, or 4 chlorines, please ask. Please ask. Like, so this is an iodine, and then that's 4 chlorines. We don't want you to make the wrong structure because you think it's an iodine, a carbon, and then 4 more iodines, which would not be written like that because you wouldn't break them up. But just ask if you need it. So here we go again. I'm going to let you figure out the clouds, though, one more time. So I would draw it out like that first, right? I do my center atom. I just give myself just a blank structure. What do I need to do? I need to be looking on the periodic table. So I need to look up I's. I need to look up CL's. And I did this one on purpose with a charge. I want to make sure we're understanding this. You got to have equal numbers. Been seeing a lot of people over the last couple days, and their T's and their V's have odd numbers. You cannot have an odd number. If you have an odd number, it's a really big red flag saying, whoops, you missed something. And usually it's just a simple electron or you added something wrong. So that's a big deal to know. You got to have even numbers. Can I have all single bonds? That's a 32. Still going to let you add these up. What does a negative do? Add or take away? It adds. I just write it right there. If you have a positive, it takes away. So I have 7 plus 28 plus 1. So basically 8 plus 28. That's 36. That's a difference of 4. So kind of wanted to just do 2 that you're adding lone pairs, and then we'll do one very different problem on the bottom. So I'd add 2 extra pairs. So how many clouds is that? Oh, 4 bonds, 2 lone pairs, that's 6. Oh, what's 6? Oh yeah, that's the complicated ones. 5 is a stick with a triangle, 6 is a stick with a square. So I just have to draw my center atom, and I make the stick, and then I make my square. Where do the lone pairs go? Top and bottom? Or side to side, technically, or side to side, but they have to be as far apart as possible. They take up as much space as possible, so you can't put them next to each other. The best example would probably be right there, but you could put them here and here, or you could put them there and there, as long as they're as far away as possible. Because I can remove any 2 as long as those 2 are removed. So if I take these 2 out, everything else is CL. I mean, sorry, that's supposed to be an I, isn't it? If you already did CL, not a big deal, but sorry. Oh, I read it wrong. That's what it would look like. Nice solid I in the middle. Shape. What is that? Square, planar, right? It's flat, planar. Shape, square, square. If it was 3, we'd say trigonal, but it's 4, so we say square. For in that shape because it's not a tetrahedral. So it's square, planar. Still 6 clouds though. 1, 2, 3, 4, 5, 6. So I have to say the whole hybrid. So it'd be sp3d2. In this case, there's not a lot of difference here. I still only see 4 bonded atoms. 4 bonded atoms. So that's a 4, no multiple bonds. Okay. And then I have to redraw this. Again, this is where students will mess this up. Now all of a sudden you do this. That's not what you drew. Try to draw it the way that it looks. It's kind of, again, looks like a cat. Last week I drew this, I think, in it. I see whiskers. Who's going to pull harder, the I or the CL? CL. CL is closer to the upper right. So I draw 4 little bond dipoles. Polar or nonpolar? Nonpolar has lone pairs, but it's still very symmetrical. These cancel out, and these cancel out. So they all cancel out, so this is nonpolar. It's very rare. If you are a betting person and you have to guess if it has lone pairs, usually you'd say polar. But in this case, it actually evens out. All right, last one on here. This is very different. A very different problem. All the same stuff we have to do, but you'll see. So carbon dioxide. So, but you figure out the T and the V. See if you can do it. This is a typical one that could easily be on the test, because we've done CO2 so much. You're doing that, I'm going to fill in the other stuff. See if you get it right.
That's just one piece.
Okay, your T. You put your C in the middle. Now, not all of you maybe drew all the dots, but you got to make sure you're seeing what you're seeing. So some of you might have drawn it like that initially. Some of you might just do this. Like the line's worth 8 then. Either way, my T is what? It's 20. It's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Why am I doing that again? All single bonds. T is basically what if I had single bonds? It's the total. V, there's 4, and then 6 times 2, there's only 16. So this isn't a negative 4, it's a positive 4. But I don't memorize that. This is what I look at. My picture has 20. I'm supposed to have 16. So I can't add dots, because if I add dots, I'm going to have more electrons, and I already have too many. So I'm either adding dots or I'm adding bonds. So how many bonds would that be? 2. So I can visually see if I add these 2 right here, and the reason why I'm not doing it in the box yet is that I got to figure out my shape. I have bonds in both of those, so I have no lone pairs. So is that bent or is that linear? It's linear. If I have a lone pair, it bends it down. So I have to have some knowledge on that. So there's only 2 clouds. So this would be my shape. You could also just add the clouds, I guess. But knowing that it only bends if you have lone pairs. So no lone pairs, it's got to be linear. So that's the shape. Two clouds, a double bond counts as one cloud. So 1, 2. So it's still just sp. And here's where it will change. How many sigma bonds? 2. Every bond area is only one sigma bond. It's a strong bond. It's the overlap of bonds, of electrons. The extra bond is what we call a pi bond, and it has to reach over the top. So I see extra bonds. I see 2 of them. Please know, however many bond lines you count, these 2 columns should equal that when you add them up. So I see 4 lines, 2 plus 2 is 4, good to go. I see 4 lines, 4 plus 0, good to go. Coincidence that they're all 4. Then I need to just redraw it. O is more to the upper right, so the electron is going to be pulling towards the O. So this is nonpolar or polar? Nonpolar, they're canceling each other out. If it was bent, it would be polar, by the way, because they'd be going downward. That is nonpolar. Okay? So those are the 3. If you go from scratch, I wanted you just to check your work on the front. And I just want to ask 2 questions quickly. So the last one. So the second last one, that was a trigonal bipyramidal, SP3D, 90, 120 nonpolar. It's apparent geometry. It has no lone pairs. So all that's really clean. It's the same answers. It has to be nonpolar. This has 6, 1, 2, 3, 4, 5, 6. We say octahedral. What's the name of the actual shape? So there's a square, and then it rises up. So it's a square pyramidal. Good. Is that polar or nonpolar? It has to be totally evenly surrounded. This center atom has an atom on top, but no atom on the bottom. So that is not even, so that has to be considered polar. Okay? So this is going to be similar to our test. So, of course, we want to have you have some practice so you are successful. And look at, we are giving you time to work on it. No, that's not.